Okay, quick video on empirical and molecular formulas. Going to run through a couple examples real quick. Start with the empirical formula. So empirical formula is a formula. And so when we're solving a problem here, we've got these percentages or these grams, and we'll notice that there are two chemicals. So like in this first one here, we have a copper piece and we have a sulfur piece. And the second one, we have a potassium, a chromium, and an oxygen. So what we need is a formula. And so the way you do this is, the first thing you do is you convert everything into moles. And that's how it's kind of looks like what we've done in the past is we're converting to moles. So we're going to work example 2. And so I'm going to use all this space here, but we're going to work example 2. So first thing to know is that a gram and a percent are going to be the same thing. If you see a percentage sign, it's going to be out of 100%. And so just make it grams. And so we have 26.6%. We're just going to convert that into grams. And all we do is just take the percentage and replace it with a G for grams. So we can write 26.6 grams of potassium. So first thing that we're going to do is we're going to convert this into moles. And we've done that a bunch. So we're just going to look up potassium on the periodic table. So just look up potassium on your periodic table, and you're going to find that potassium is going to be 39.09. And so you just look that up on the periodic table. So I just got that value from the periodic table. And so right here, you're just looking this up, and you're getting the 39.9. So that's going to give us our first answer in moles. Now I got to do the same thing with the chromium, and I've got to do the same thing with the oxygen. So I'm just going to write those out real quick. So the chromium is going to be 35.4 grams. See, I just replaced the percent with a gram. Chromium. And then here we go. It's going to be a little tight with that line. So let's go ahead and do 1 mole over, and again, this is the mass of chromium. I'm going to look this up on a periodic table, and that's going to be 52.00 on our periodic table. So again, I'm just looking these up on the periodic table. That's going to give me my second answer, and then the last one is going to be the oxygen, and you guys have done a lot of these mole conversions at this point, and so hopefully you're starting to figure some of these out. Now notice that I'm just doing the same kind of thing that we have done over and over, converting to moles. So this is our first step. So we're going to run this through a calculator, and we're going to get 3 answers. They're going to be in moles. So 26.6 divided by 39.09. Run that through your calculator. 26.6 divided by 39.09. And that's going to give us a 0.68. And so this is going to be 0.680, and that's moles. And the chromium is going to give us when you take 35.4 divided by 52, you're going to get 0.681. And these are basically the same number. And then this oxygen here at the bottom, we're going to get a 38.1 divided by 16, and that's going to be 2.38. So a little bit different, 2.38. Okay, now here's where people make the mistake. What we want to do now is we want to divide every single one of these by the smallest, all right? So when I'm looking at these, we've got 0.68, 0.681, and 2.38. So 0.68 is the smallest. And so we're going to divide each of them by the smallest. And so I'm picking 0.68 because it's the smallest one. So this is the step people mess up on. They forget to do this. And I'm going to show you why this is valuable here, because we're trying to get to whole numbers. Okay, so when you do the math here, 0.68 divided by 0.68, that is obviously going to be 1, right? 0.681 divided by 0.68, that's basically also going to be 1. But 2.38 divided by 0.68 is going to be 3.5. Okay, so we are looking for a formula here, all right? So we're looking for a formula. I'm going to slide this down and get a little more space. And our formula is going to be 3 components. It's going to have a potassium, a chromium, and an oxygen. So right now, this is saying, hey, you've got a 1, a 1, and a 3.5. Well, if we plug those into our formula, that's going to look a bit silly. And so when you plug this in, if you have a K and a CR both at 1 and an O at 3.5, that's not going to make a lot of sense. We're not allowed to use these partial or these decimal values. You can't have 3.5 oxygen. So to fix this, we're going to multiply all of these by 2. Now you only do this if you can't round. And so I say you can round if you're within like a tenth. And so let's say that you had 3.95. Well, go ahead and round that to 4. That's fine. Or if we had 2.06, well, we could round that to 2. But 3.5 is far too big to round. So if it's not within a tenth, you can't round it. So you need to look for a multiplier. The multipliers are easy to spot. They're going to be times 2, times 3, or times 4. So in this case, it's going to be times 2. So what I tell students, if you have like 0.5s, you're going to multiply everything by 2. If you have like 0.33 or 0.66, that's going to be a times 3 for everything. And like 0.25s or maybe 0.75s, that's going to be times 4. These are really the only ones that come up, times 2, times 3, or times 4. Since we have a 0.5, we're going to multiply all of them by 2. And that's the thing is that when you multiply, they all have to be multiplied by the same value. So we're going to come up here and we're going to take 1 times 2, 1 times 2, and 3.5 times 2. So the numbers, and I'm kind of running on my space here, the numbers you're going to end up getting, you're going to get a 2 and a 2 and a 7. And so that's what's going to become your formula. So what you do is you just go back and you look, okay, so potassium gets a 2, so it's going to be K2. Chromium, right here, it's going to get a 2, so Cr2. And then O, which is right here, it gets the 7. And so I just kind of use that order right there. So then it's going to be O7. And that's the answer. That is the formula, and that's the empirical formula. Empirical meaning it has been reduced. And so you'll notice 227. This is the simplest formula, and we've determined it mathematically. So an empirical formula, what we're after is that simplest formula. Now, this is a pretty complicated example. When you try example 1, it's going to be much less complicated because you only have 2 chemicals and you're not going to have to do this multiplier. So go ahead and try example 1, see what you get. Okay, so I went ahead and did example 1. Hopefully you paused the video and tried it yourself. So if you look, I just converted the copper into moles. I got this 4.39 number right here. And then I converted the sulfur into moles. Got the 2.2. 2.2 was the smaller number, and so I divided them both by that smaller number. And what I ended up with when I divided them both by that smaller number is I ended up with a 2 and a 1. And so those became my formula. So if you look right here, I have a copper 2 and I have a sulfur 1, so Cu2S. And so that's the second example for you. I'm going to drop down here now and look at the last one, which is the molecular formula. So just kind of, as we're talking through this, see, an empirical formula is like CH4 because it's simplified. It can't be reduced. But like C3H12 is not simplified. I could actually divide both of these by 3, and I would get CH4. So basically, you have the empirical, which is the reduced, and you have the molecular, which is the not reduced. And so that's what we're going to be looking at here, is how do we build the molecular, and we're going to build that from some mathematical data. So it's really straightforward. So what we're going to do is we're going to start by looking at what they gave us, and they're going to give us a number, 181.5, and they're going to give us a formula. Now that formula is already empirical, it's already simplified. It is the smallest version of this chemical. And then there's this mystery version, and the mystery version is some multiplier of this. So the mystery version is something that we don't know, but we're going to use this formula to find it. So like it might be like times 2, times 3, times 10, who knows? So it's going to be a mystery formula, and we're going to go ahead and figure that out. So it's some multiplier. Multiplier could be times 1. So real easy, what we're going to do is we're going to first add up from our periodic table. We're going to go to the periodic table, we're going to add up, what does this weigh? C2HCl. So we're going to add that up on the periodic table, and then we're going to go ahead and compare that to 181.5. So that's what we're going to do. All right, so what I did is I went and I looked on the periodic table, and I got all of our values. So there's value for value for carbon times 2, hydrogen, just one of those, and there's my chlorine, all from the periodic table. Just looked them up, add them up, and then what I got is this 60.48. And so this 60.48 is what we're going to be comparing. And so what you do is you take the number they gave you, which was again right here, 181.5, and you're going to take that number, 181.5, and you're going to divide it by this number. And this number should always be smaller or the same. There is a world where it's the same number, but right there, smaller or the same. So it is smaller, so 181.5 divided by 60.48. Going to do that in your calculator or in your head. And what you're going to get is 3. And so what we're saying is that the mystery chemical is 3 times the starting chemical. So you just multiply by 3. So just get a little space here so you can put our final answer in there. And it's really straightforward. So what we're going to do is we're going to take our formula that we started with right here, C2HCl, and we're going to multiply it by 3. So it's going to become C6H3 and Cl3. So I just multiplied all of those by 3. And there you go, there's your molecular formula. And so now you kind of have an example of how to do both molecular, and then up here we've got the empirical. Now you could see both of these problems kind of combined. So if we kind of look down here at the practice, you'll notice these are just all empirical, just finding that formula. And again, percents and grams, they operate the same way. Down here, these are molecular, so this is like example 2. And then down here, number 9 and number 10, these are combinations where you're going to be basically finding the empirical and then finding the molecular. So you're going to do both things here. And so that's what's going to happen there. So these are going to be a little bit more challenging here, but not super difficult at all. So good luck. Hopefully this helps you out, and ask me if you have any questions.